Heat transfers. Throughout this entire unit, we're trying to answer this question, this essential question. It says, how does the surface of the Earth get heated? Well, there's two possibilities that the surface of the Earth can be heated. The first is going to be from the sun itself, and the other is from the inside of the Earth. But before we really get to how the Earth is heated, we really have to talk about what heat is first. So what is heat? All matter in the universe is made of little particles, atoms, or molecules, and they are always moving around. So in this diagram right here, you see a bunch of like little particles that are just vibrating back and forth. That's essentially what the heat is. The motion and vibration of these particles, which we call kinetic energy. The kinetic energy inside of these particles as they're vibrating around, that's the heat inside of the system. And then the faster that they move, that means that they have more of that kinetic energy, which means they have more heat. So they're vibrating around more when they have more heat. Now let's not confuse the term heat with temperature. Temperature is the average kinetic energy of its vibration throughout the entire system. So the average kinetic energy is temperature, but the heat is the total kinetic energy of the vibrations within the system. And that what we use to measure the amount of temperature in a system is Fahrenheit, Celsius, or Kelvin, depending on which scale you want to use. But in determining heat, since it's energy, we use joules to measure that. So to recap, heat is the total energy in vibrations of the particles in a system, and temperature is the average kinetic energy per particle. Now, in order to get an actual heat transfer from one object to another, basically what's going to happen, there are three possibilities in order for heat to transfer from one thing to another. The first is going to be conduction, the second is convection, and the third one is radiation. So first of all, in talking about conduction, essentially what's happening here is you get particles that heat up, which basically increases their kinetic energy. Now, as they increase their kinetic energy, they transfer it over to the next particle, and then that particle heats up because now it has more kinetic energy, and that those particles keep colliding into each other, and that kinetic energy keeps transferring outward. Well, those collisions that transfers this energy out away from the heat source, that is referred to as conduction. So particles close to each other, they collide, and if one particle has more kinetic energy, it will transfer its energy over because heat always transfers from hot to cold. That's just a natural progression of how heat is transferred through a system. It always goes from the hotter to the colder. The next type of heat transfer we call convection. In liquids and in gases, the warmer material is less dense. So as a material heats up, it'll actually become less dense. Now as a material gets less dense, what it does is it rises up, and the more dense, cooler material will drop down below it. So because this material is getting heated up, it becomes less dense. And basically what you get is you get the hot material that's rising up, and the cooler material falls in to take its place. Process, as warmer material rises and cools, it cools down when it gets up to the top. So as this warm material gets up to the top, it'll actually get cooler, and then it'll drop back down, and then the cooler material underneath will actually heat up, and as it heats up, it'll come upward. And basically what you get is you get a cycling of this material as it goes around, and we refer to that as a convection current. So essentially we get the air, let's say for this heater right here, the air is heated up, it rises up naturally. As it rises up, it cools off by transferring its heat to the rest of the air around it, and when it cools off, it comes back down to the bottom, and then the cool air at the bottom gets pulled up in here, because basically when the hot air rises, it leaves a vacuum, it leaves an empty space, so the cool air comes in, and then it gets heated up and comes up around, and basically this whole cycle where it transfers its heat up here and then comes down here and gets more heat, that's referred to as a convection current. So in this video right here, what we see is that the rice is actually in the center, is coming up, and as it comes up, when it gets to the surface, it goes towards the edge and then drops back down on the edge. Now as it goes around, basically the water, it has a convection current, and it's not easy to see those convection currents, which is why the rice is in there. And the rice basically shows you that that the water is coming up, cooling off, and then as it goes back down, it creates that current circling around. So the third type of heat transfer is called radiation, and basically everything that has heat emits an electromagnetic radiation, some sort of wavelength. So some examples include the universe. The universe itself is at a really cold temperature, so it's at a very low frequency, which is a microwave range. Your body heat is actually more in the infrared range. That's where our infrared goggles come from in order to be able to see body heat. The sun is more in the visible and ultraviolet region of the electromagnetic spectrum. That doesn't say that the only visible light and ultraviolet light is the only thing that comes from the sun. It just says that's where it peaks. That's where most of the electromagnetic spectrum comes from for the sun. And then neutron stars even have X-rays and gamma rays, which are really high energy and dangerous if we're in close proximity to it, which fortunately we're not in close proximity to that. So if you have a fire or something, usually the first thing you feel off of that fire is not conduction or convection, but it's actually the radiation that's coming off. It's the heat through radiation that hits your hands. So if you look at all three of them together, basically you got a fire right here. And if you've ever had some sort of a metal pan that has a metal handle and the entire pan is metal without having any individual part for the handle itself, then you may have noticed that when one end gets hot, like when you place it on the stove, then the handle gets hot too. That's by conduction. And then the fire will heat up the air, and as the air heats up, it will rise upward, which gives you your convection. And then the radiation, of course, is from the heat of the fire itself that'll go off. Actually, the radiation will go off in every direction, but this shows that it goes off sideways.